Hello, welcome back. Now we're looking at another type of experiment, which we call block design. Now, block design is similar to is in, like the totally randomized experiment. There's just another layer to it. We separate uh, people up into two groups before we run the experiment, and we have to separate them in some way that's expected to systematically affect the response of the treatments. So, for instance, this is one about cancer treatments. They think that, or they know that men and women respond differently to different cancer treatments. So, since we know that coming into the study, what we do is we take all of our subjects and separate them into men and women. Once we have our men and women in separate groups, then we want them to go to a random assignment into the three different groups, or which corresponds to the three different therapies that this study is going to provide. And then we want to compare the survival rates at the end. This separates out some variable so we don't happen to think that there might not be a connection when there might be. Maybe if everybody was together, we would see that the cancer rates don't improve, but maybe the cancer rates just improve for women, and we would miss that if we didn't do the blocking. Um, for instance, here a fitness instructor wants to see the effectiveness of his upper body workout. He initially tests people on the amount of push-ups they can do in a minute. He wants to compare people with similar abilities. So in this case, uh, there are a couple things that he can do. He can separate them into two groups, or he can do something called a paired sample. Paired samples are when each data point in one sample is matched up to a unique data point in the second one. Specifically, it's called matched pairs. It's the common form of blocking when we're just comparing two treatments. So the fitness instructor can take the people on the bottom. Maybe he initially tests people, he tested their push-ups, and maybe they can do 0 to 10 push-ups in 1 minute. And he'll take and if whatever however many there are, but usually with matched pairs there's just two. So maybe I should change that to be the two bottom, two lowest um, amount of push-ups, and then there's the next two, and then there's the next two, and he keeps on going, and he would create blocks, but there'd be many blocks of just two people, and once he creates all those blocks, then one person will get the control, and he has to randomize it, and one person will get the treatment. And then he can compare his results. Now, typically there are two types of matched pairs. One is like we're talking about here, where you split them into groups of two, and one person gets the control and the other one gets the treatment, and then you compare the results. There's another one where each subject receives both treatments, but in a random order. Uh, so, um, so you could do match pairs, and sometimes they call these before and after. So in this one, instead of pairing them up, what they can do is just take this. The previous one doesn't really work, um, but let's say we could test right hand, left hand coordination. So if we're going to do coordination, um, we can do something with the dominant hand first, and then we do it with the non-dominant, and we'd want to randomize those orders, and then we'd want to see how we could compare the difference of, of one or the other. But in this one, each subject is receiving both treatments, doing it with the dominant hand and the non-dominant hand, but we would randomize which order they're in, and then we can compare just that one. There was an AP test question years ago about waterproofing boots, and the goal was to set up um, an experiment to test a new waterproofing technique for the boots, and they wanted people to figure out what's the best way to run an experiment on that. And what they wanted people to get is they wanted to use a match pairs design, where each person would wear two boots. Uh, one boot would be old waterproofing, and then one boot has the new waterproofing. And so each person would do this, and then they would randomize who gets the new and who gets the old. And then you can really compare how well they last. Because if we randomized the some boots that to people who to different people. Some people walk a lot in the woods. Some people don't walk very much. Maybe they walk on city streets, and their wear would be different. So this way we would be able to compare these two and see exactly how the waterproofing works for that particular person. Now, when you're doing an experiment, one thing to think about is sometimes it helps for the experiment to be double blind, where neither the subject nor the person who's measuring the response knows which treatment the subjects receive. Now, when is it a good idea to do this? There should be a question mark. We do this when there might be some when there might be some influence on the person taking the treatment or giving the treatment. Say if we were in a hospital and a nurse knew she was giving a sugar pill to a patient rather than the actual pill, she might actually put it lower on her list of things to do, um, and and she just probably wouldn't care, or maybe her demeanor when she's administering it might be different, and that could skew the results. Likewise, if somebody knew they were just taking a sugar pill and instead of aspirin or whatever it was that they're trying to use, um, they would wouldn't want to feel like they were fooled, and then they wouldn't have the effect. All right, now try your on your own. Good luck.